Hello, boys and girls. Welcome to another lovely video about probability. Today we're going to talk about the fundamental counting principle. It's a pretty easy concept to understand. To demonstrate, I'm going to use Lego Friends. Okay, so I've got two, right? Now you can take them apart, and there's hair, there are heads, there are bodies, and there are legs, right? My daughter just realized I took them, and she's cracking up, so. Thank you, Adrian. Could you? This is math class. This is the fundamental counting principle. Now, because I have all these different pieces, I can make different combinations of course, I can put them back the way I had them. So there's two hairs, right? Two heads, two torsos, right? And then two legs. So there's all kinds of different combinations. You can have this body with this head and these legs and that hair. You can mix them all up. It doesn't matter. There is a finite amount of combinations, and you can figure this out by doing a large map. So let's start with the heads. I'm going to make that my starting point. So I can either do, I've got the light skinned and the dark skinned. So I got light and dark. All right. Now once I choose one of the heads, I'm going to choose, let's say, a hair. And the hair, well, there's blonde. And then there's brown. So BL for blonde and BR for brown. So it's the same choice right here, BL or brown. And then I can do bodies. Let's see, we've got pink and white for the shirts. Pink and white, or pink and white, pink and white. Oh, they're starting to get all crazy here. Pink and white. And finally, we've got the shoes. Or the shoes or the legs. Let's see, what do we got? We've got green and pink. So here we go. Green and pink. Green and pink. This is getting a little bit off here. Green and pink. Green and pink. And I'm down here now. Green and pink. This one. Green and pink. Hey, guess what? My dinner's done. My wife is making something very interesting in a crock pot. Okay, so that is really messy because I didn't give myself a very good distance between these two. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different possible combinations I could make. Whew, that's a lot of work. It might remind you kind of the same kind of tree I made when flipping coins. And when we flipped coins, we realized we could just multiply the 2 by the 2 by the 2. This is the exact same thing. 2 hairs, 2 heads, 2 torsos, 2 legs. 2 times 2 is 4, times 2 is 8, times 2 is 16. That gets us all the possible combinations. Now, let's think of some other things we could do. Let's say we're looking at clothes. We're going to have, well, your whole bodies. Let's just do, we're going to do tops, shirts, right? And we're going to do some pants, and we're going to do some shoes. So let's say the tops, you've got 9 different types, 9 different tops, and you've got 6 pants, and you've got 3 pairs of shoes. Instead of trying to do a giant tree, you can just multiply all 3 of these together and find out how many possible outfits you could make, assuming they just don't look good together. So here we go. We've got 9 times 6 times 3. That's going to be 54 times 3. 50 times 3 is 150, plus 12 is going to be 162, right? So 162 possible combinations. So here you go. This is your practice sheet. I noticed I called it the universal counting method. It's really the fundamental, so ignore that. But pause the video. You should have this attached. Print. You can just write down the answer somewhere. You don't even have to print it out, right? But pause it, and then we'll go over that. Okay, here we go. We're looking at the Snorlax Snack Shack Surf Sundays, and you can choose one flavor of ice cream: chocolate, vanilla, strawberry, cookies and cream, or mint chip. For sauces, you can choose hot fudge, strawberry sauce, or caramel. Toppings, you can either have nuts or not have nuts. So we're looking at how many possible combinations. So looking at the ice creams, there's chocolate, vanilla, strawberry, that's 3. Cookies and cream, mint chip, that's 5 ice creams. So there's 5 of those. Sauces, got hot fudge, strawberry sauce, and caramel, so that's 3. And you can either have nuts or not have nuts. So that's your nuts. So 5 times 3 times 2. 15 times 2 is 30. Possible combinations for that one. For the second one, Susie and Jimmy, we're playing the Perfect K-Rock Concert Draft. You get to choose one headliner. You can choose the Foo Fighters, Muse, the Red Hot Chili Peppers, U2, 21 Pilots, Green Day, or the Killers. That sounds like fun. You get to choose one showcase act: Fitz and the Tantrums, Walk the Moon, the 1985 Arctic Monkeys, and you get to choose one opener: The Interrupters, Cold War Kids, Mumford and Sons, Of Monsters and Men, or Judah and the Lion. So let's see. We've got our headliners. Foo Fighters, Muse, that's 2. Chili Peppers, U2, Pilots, that's 5, 6, 7 total. Our showcase act, the guys in the middle: Fitz, Moon, 75, Monkeys, that's 4. Then our openers, we've got Interrupters, Cold War, there's 2. Mumford and Monsters makes 4. Judah and the Lion make 5. So 5 times 4 is 20. 20 times 7, there's 140 different show combinations we could have there. Who would you pick to be your headliner? I've seen the Red Hot Chili Peppers. I've seen Green Day. I've seen the Foo Fighters. So I'd probably have to pick between the Muse. That'd be fun. U2, that could be fun too. I heard they put on a good show. 21 Pilots, yeah, or the Killers. 21 Pilots would be cool. Anyways, moving on down. My mom was making sandwiches. We could either have wheat bread or sourdough. We could choose turkey, ham, or salami. We could have mayo or no mayo, cheddar cheese, pepper jack, or no cheese. So, what types of breads? We've got wheat or sourdough. That's 2 options. For the meat, turkey, ham, and salami is 3 options. For the mayo, it's either yes or no, so that's 2 possibilities. And then for the cheese, cheddar, pepper jack, and no cheese, there's 3 possibilities there. So that's 2 times 3 is 6, and look, 2 times 3 is 6, and 6 times 6 is 36. So 36 possibilities. There's another kind of format I'd like to talk about, and that is the lock. Can you stop that, please? This is not like the lock you guys have at school to lock your gym locker. You guys have the turning ones. This is the wheel, or the tumbling. I call them tumblers. I don't know why I call them tumblers, but I do. So there's 3 here, and they start at 0, go all the way up, 2, 3, 4, 5, 6, 7, 8, 9, back to 0. So from 0 to 9. And there's 3 of them. So you can make 181, you can make 455, you can make a lot of different numbers. First, let's remind ourselves that 0 to 9 is all of our single counting digits. That is all 10 of them. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all 10 of our numbers. So when you have 10 in each tumbler or wheel, using the fundamental counting principle, there's 10 possible digits you can have on the first wheel, tumbler, 10 on the second, and 10 on the third. So 10 times 10 is 100, and 100 times 10 is going to give you 1,000. So this lock has 1,000 possible combinations. So starting with 0, 0, 0, you could try it. 0, ooh, I popped it open. It was something. Cool, I opened this one. Yay, I'm awesome. Probably because we haven't set this lock yet. Anyways, what would happen if I had 4 tumblers? I had 4 different wheels, each one with 10. Right? 4 tumblers? That'd be 4 of those little guys. 4, 9, 6, 3. That's 10 times 10 is 100, makes 1,000. 10,000. That one tumbler makes a big difference. If someone said, hey, open this lock, and there's 1,000 combinations, just sitting around watching TV, I'd probably pop it open in just a day, just fiddling around. But 10,000 is going to be a little more discouraging, and I probably wouldn't do it. So that extra wheel really makes it a lot safer. Now the type of locks that spin, the locks you guys have, I don't have one here at my house. In your locker, right? You've got like 0 and 15, and I don't know how many there are actually. I think it's like 36 or something like that, if I remember correctly. But you have to spin it around. It's 3 turns, and I'm gonna say there's 0 through 36. That kind of sounds right to me. I don't have one here at my house to double check. I guess I could have gone on Google before I did this, but who cares? It doesn't make a difference. It's gonna be 3 turns. So 0 to 36 is how many different numbers? 37. So since we spin it to one number, spin it back to a second, and then one more to the last one that pops it open, that means it's 37 times 37 times 37. That's a lot of possibilities. Let's see what that is on this trusty calculator. 37 times 37 times 37 is 50,653. That's the worst comma I've ever made. It was like making the top of a 6 instead of the comma. 50,653. That's a lot more than 10,000. No one's going to want to do that. That's why people just break these locks, because no one's going to try and get the combination. It's a lot more secure lock. One last thing we'll talk about before I let you go, because we're not really going to practice these. These will be on your homework, is license plates. License plates in California, your standard plate has 7 terms, digits, or numbers. It starts with a number. Then it has 3 letters, followed by 3 numbers. Now, of course, the numbers are 0 through 9. Right now, they're on 8s. My car starts with a 7. My old one started with a 5. So they'll rearrange it at some point and create a whole new system. This does not include any of the custom license plates. This is just your standard ones, not the ones you pay extra for that add different symbols and make it even more combinations. And you can also only do 6 letters or only do 5, and so it really changes up the possibilities. there are going to be 10 of each of the numbers. So we already know there's 10,000 right there. How many letters are there? There are 26 letters in the alphabet. So each letter has 26 possible combinations. And then the 10, the 10, and the 10. So I'm going to need to pop out my calculator for this. 26 different letters and 3 spots. Times 1, 2, 3, 4 tens. Can you see that number? A little glossy right there. Let me see. I don't even know where we're at. All right, 175,760,000 possible combinations of that license plate. That's a lot of different combinations. Now, you might think, well, that's not enough to cover everyone forever, and that's true. It's not. But that's like about half of the population of the entire United States right there, and that's just for California. Now, if you wanted to think about this, just changing one number to a letter is going to add a ton of difference. I could show you that right now. I divide by 10 to take one of those 10s out, right? And then I multiply by a 26, and now that goes up to, let's see, 456,976,000. So just changing one number to a letter, look how many more combinations there are. That's way more than the population of our entire country. And also, they could just rearrange the order. They could have 2 numbers followed by 3 letters and then 2 numbers, or they can do all kinds of different variations, and that's why this combination is so is being used. It's also why when you're making a password, they ask for uppercase and lowercase, because that turns the 26 into 52 combinations, and then they want you to use all the numbers. So each space can also be, we're going to add this up. If you use all the numbers, and then all the special characters, which there's another 10 of those, right? If you're using those in a combination, each different space of your passcode for a computer has 50, 60, 72 possible numbers. So let's say your passcode is 8 digits long. I'm not even going to be able to figure this out. I bet my calculator will just say no. 1, 2, 3, 4, 5, 6, 7, 8. I wonder if I can just do that exponentially. Let's see, 72. Let's try this out. I'm going to do x squared. Let's see if I can go back and change it. Ooh, I can change it to an 8. No, I want it to be an exponent. Let's go up and see if it... No, that didn't work either. Oh well. Let's try that again. All right, so we're going to do 72. That's 1, 2, 3, 4, 5, 6, 7, 8. Okay. That is... Okay, I can figure this out because I know this number. It's 7.222041363 times 10 to the 14th. So 7, I'm going to go 1, 2, 3 2s, 0, 4, 1, 3, 6, 3. And that's 2, 4, 6, 8, 9, 10, 11, 12, 13, 14. Okay. Okay, so there's millions, billions, trillions. So that's why they want you to do that with your passwords and computers, because right now we have 722,204,136,300,000 possible combinations if you use capitals, lowercase, numbers, and special characteristics, or special characters, or whatever they're called. So that is the universal counting method, or counting principle, if you will.
I hope that makes sense to you. Talk to you soon.